In the first unit, we saw how deep learning fits into the overall data science landscape. Now it's time to get our hands dirty. I'm going to present 4 case studies that are found in part 1 of the Deep Learning with R book, and as we go along, I'll introduce you to some of the fundamental concepts. At the end of this unit, you'll have a good overview of the deep learning foundation upon which a wide variety of deep learning applications are built. This will allow us to dig deeper into subtler analytical questions in the next part of the video series, where we'll see all these concepts in action with more complex data. The first case study is a classic in machine learning. Think of it as our hello world. It's a collection of 70,000 labeled images of handwritten digits from the US National Institute of Standards and Technology. Our goal is to train a neural network to properly classify the images. I'm going to go through the code in the book, but I'll also dissect the case study piece by piece and visualize the deep learning process in an intuitive way. We're going to see a lot of the new terms which I presented in the deep learning landscape in the previous unit. We'll look at network architecture and tensors, which will lead us into the mathematical engines that power deep learning, matrix algebra and calculus. You'll understand what derivatives and gradients are and see how they come into play as gradient descent, and we'll look at some common implementations of a variety of different types of functions, including loss, optimizer, and activation functions. And finally, we'll see how backpropagation ties up everything nicely with the chain rule. I think of matrix algebra and calculus as the engines of deep learning. Of course, you can drive a car without knowing anything about the engine, but even some basic knowledge will help you identify and fix problems along the way. So if you're familiar with matrix algebra and calculus, that will come in handy. If you're not, don't worry. I'm not going to assume any prior knowledge. I'll sketch out the operations described in the book, and you'll pick up the basics pretty quick. I'll go through examples of matrix algebra using our actual input data and model to show you how it works in practice. And that's really the beauty of this data set. We're literally going to look into our network and visualize how we can classify images in an intuitive way. There's one more thing that I need to mention at this point. For the first part of this course, the case studies are small enough that you can run them on a laptop with a reasonably powerful CPU. But we typically perform deep learning on a GPU instead of a CPU. I'll explain what the difference is and how to get access to a GPU in the second part of the course, where the case studies are larger and computationally demanding. Alright, that's enough background. Let's move on to the next module and look at the MNIST case study in action.